afternoon, everyone, and welcome to our latest episode of MSME Masterclass. We are honored to welcome Mr. Manish Garg, a stalwart in the Indian steel construction industry and a name synonymous with pioneering innovation in the pre-engineered building space. Mr. Garg is a distinguished alumnus of Harvard Business School and a civil engineer from Delhi. He brings with him over 30 years of rich and diverse leadership experience. His strategic vision has been instrumental in transforming India's metal building systems sector and beyond. From launching metal roofings in the early 90s to building the rupees 500 crores vertical at Everest Industries from the ground up, Mr. Garg has consistently been at the forefront of redefining how steel is used in modern construction. His work in Kenya with Suffolk Building Systems further exemplifies his global perspective and impact, where he played a vital role in reshaping construction practices across the African continent. As the CEO of Interarch Building Products, one of India's largest and most respected metal building solution providers, Mr. Garg continues to champion sustainable practices, operational excellence, and technological innovation. Under his leadership, Interarch has solidified its market dominance while exploring new regions, markets, and possibilities. Known for his analytical acumen, leadership capabilities, and transformational mindset, Mr. Garg's contribution has led to measurable business growth and redefined industry benchmarks across engineering operations and safety. Please join me in giving a warm welcome to Mr. Manish Garg for today's session. Welcome, sir. Welcome on board.
Thank you. Thank you, Amrita.
So our topic for today is the future of construction with steel, and I'll quickly jump on to our first question for you, which is how do you foresee steel evolving as a primary material in construction over the next decade, especially for MSMEs?
Okay. Steel we all know has been associated with any country's progress quite directly. In fact, if we were to see the direct relationship between a country's GDP growth and the usage of steel, and particularly in construction, there is almost a direct relationship. So the moment a country starts to grow fast, the steel consumption per capita starts to grow. Or we can say vice versa, that a country has to start using more and more steel in construction, because steel is a wonder material in terms of the speed, longevity, and convenience, if I was to say, and add to that the sustainability part of it. Constructing with steel comes with a lot of convenience, a lot of finiteness, because MSMEs in particular means they don't have unlimited capital. So they need to use every single paisa of their hard-earned, money whenever they are setting up new plants or whatever, very cautiously. Steel helps them build fast, build uniformly, build for longevity, and even at the end of the life cycle, they can get a lot of value in salvaging. So imagine if there was a building constructed 50 years ago in concrete. You break it down now, you will have to pay for, taking it away. However, just imagine if you constructed a building in steel 50 years ago and you take it down now because the life is over and you want to rebuild it. Perhaps you can get as much, money that you may not have spent even that time, and it is recyclable. So I think it helps. So I see complete synergy in the steel being the primary material for construction when it comes to MSMEs, or for that matter, any construction sector right now, because of the speed and convenience.
Got it. Sir, could you also highlight, what recent innovations in steel usage should MSMEs pay closer attention to stay competitive in the market?
Yeah. So I think there have been several innovations. One of them is the advent of high tensile steel. Earlier there was only one grade available, which we used to call, commercial grade 240 MPa, 250 MPa, and you had to make good only with that. Earlier, the availability of the flat steel also, or the cold rolled steel, or the color coated steel, value added, was not as much. Everything had to be, made out of using those standard rolled sections. So I would say that one innovation has been the availability of various types of steel, various grades of steel, which has made making steel usage far more economical in terms of you can do mix and match. So now you have steels which are high tensile grade 50, 345 MPa. You have very highly of course JSW and many other companies do make those kind of steels. So you have very high grade steel. So if you are building somewhere near coastal, you have a steel external for that. You have galvalume kind of a steel for that. You have color coated, you have galvanized various steel matters for that. So I would say one of the innovation has been various types of steel which can give you fully optimized building. Second is, I will say, the level of prefabrication in steel has gone way high. Earlier, everything will have to go to site and everything will happen at site. You cut it, you bend it. So it used to have a lot of component of labor at site and a lot of inconvenience, a lot of power would get used. The quality may not be as great as of a I think we all now have shifted from our parents' time, when they used to take us to a tailor and tailor will take measurements and we will all be very happy getting those new clothes stitched. I hardly see now people getting their clothes stitched. Everything is ready made. People have shifted. They're better finished, they're fast, they're economical. So same is the steel innovation, that a lot of prefabrication does happen, wherein companies like ours, there are hundreds and thousands of companies which can do prefabrication, and a lot of MSMEs have used their prefabricated components or the buildings to get their buildings up in less than half the time. So, and third and the most important, I would say, is the prefabrication of as much as possible in the factory. Pre-finished material goes to the site. So in terms of the pre-finished material means pre-painted, even the structures can go and come up in no time. And finely engineered building through the intervention of the structural engineering softwares, I should say. So these are, I think, three things: high grade steel, prefabrication, and pre-finished component supplied has completely changed through this innovation.
Got it. So could you also share an example where steel construction significantly reduced costs or timelines for a project?
Okay, so I would say the example which is the best, and I think which resonates with everybody, because I'm sure most of the people listening to this program would have taken a flight from Terminal 3 of Delhi International Airport. So we had declared that Commonwealth Games 2010, and this Terminal 3, which was the biggest airport India was building, had to come up. Initially, the designs were made using 13,000 tons of steel. And when it came to prefabrication, and as I said, usage of high tensile steel and all, a company like us could do the steel optimization by 4,000 tons. The entire project came up in 9,000 tons instead of preconceived 13,000 tons. And also, in place of 16 months envisaged, this was done in 10 months. The steel work and the roofing work of the entire Terminal 3 Delhi International Airport. So I think that's one example which, of course, and I can cite it because it is so publicly spoken, available. It's a public building, so there is no restriction also of anybody talking. But I think, and there are hundreds and thousands of examples, but this comes nearest to our heart, because we were also we were chiefly involved with the Larsen and Toubro in doing this entire thing, and perhaps that was one of the projects which was up and running in time for the 2010 games. So that's one real life example which I think next time any one of us passes through that terminal through for a flight or lands there should remember that is the magic steel did to that terminal in terms of cost savings and time savings.
That's a great example, sir. So moving on, what role does India play in global advancements in steel for construction, and how can local businesses benefit from it?
Yeah, so I would say the first one, I'm not very sure because Americans, and Empire State Building is one of my favorite building. Whenever I am in New York, I make it a point that I see that building, go there every time because number one, I'm a construction professional, then we build in steel. So just imagine 100 years ago, Empire State Building, when the steel and this thing was not so popular, the cranes were not available, was done in 13 months. Means that's the kind of speed that they built at. So I would say India leading the innovation in steel construction, I'm not very sure because steel frankly has been used much better and in a much wider way in the Western countries, much before us. Britishers, you see how our all steel bridges and all came up in the British era. I would say India recently, in last 10-15 years, have caught up with the Western world. That much I can say. We were far behind. Now we are more or less, sort of rubbing shoulders with whatever should be done in steel is being done in steel. But yes, I think we can do a lot more than we are doing right now. So I'm sure that right now, agencies like INSDAC, steel development, industries like CIDC, construction industry, they are all Government of India initiated, I think INSDAC comes as a SAIL, initiative, and a lot of steel companies are involved, CIDC. I think ISA also, Indian Steel Association is, wherein all this. So I think we can see a lot of traction finally in India towards let's build India of our dreams in steel. We go to Central Vista. I think the most talked about project has all been built in steel, never thought of. We talk of Dwarka Convention Center, steel. We talk of the, that Pragati Maidan thing, Bharat Mandapam and all those new buildings, all steel. So I would say India is finally catching up, and even the Bureau of Indian Standards is coming out with new renewed codes, which will make the use of steel far more better and far more possible. And so I will say India is adapting. And I think once we have caught up fully, perhaps we can take some, leadership positions also in how can we use steel better. And we have seen India, there are Indian leaders who are leading the global giants also now. So I think as Indians, we are quite fast in catching up and then taking, giant leaps also in taking things ahead. So I'm sure. But right now, I will say we are catching up fast.
Okay. So, are there any emerging types of steels or treatments that could revolutionize how we build in the next 5 years?
Yeah. So we just had, I think, one of the interactions with people who build in steel a week ago, and this was one of the topics. And two things came up, Amrita. One was there are, I think, some developments which are being done by the major steel, manufacturers in India, the likes of JSPL, JSW, and all those kind of major players in India. One is can we look at a fire retardant or a fireproof steel? Fireproof, not something that is very possible, and I'm sure that there have been some developments which we are aware of at major steel companies wherein they are developing fire resistant steel. Now that can be one major contribution from the steel suppliers. And second is, can we do more of high tensile steel, which is 450 MPa and more? So you can use lesser steel, lesser sections, and make skyscrapers or anything of that sort. And third is, can we produce more corrosion resistant steel from factory compared to what we produce now? Because these three concerns, fire, corrosion, and strength, I think if we can take this to the next level, I think that can really be a game changer. And we see that happening. I think a lot of steel major manufacturers are trying a lot in R&D. I think these three are the gaps I should say one should be looking at.
Got it. Well, moving on to quality assurance, in your opinion, how can small scale manufacturers or builders ensure quality assurance when sourcing steel for their projects?
I think that's a that's a tough one. Uh, there is this big market, what we call secondary steel, right? And there is primary. When we look at the Indian construction sector and MSME building and builders and all, I think for a 10 to 20% price difference, a lot of people tend to shift to secondary steel. They don't really realize, the same person will buy, an iPhone 16. There, they don't go for, a duplicate or whatever. They realize the value that, when they buy an iPhone, it will not have virus, it will be, trouble free, it will have this or that. But when it comes to making their home or a factory, there's a steel, okay, let it be, whatever. I feel primary steel delivers significant benefits. Number one is, it's like eyes closed. If you're buying a primary steel from one of the main manufacturers, it does the job. So I would say that people have to, start thinking the long term. You don't do construction for 1 year or 2 years or 3 years. You do it for 50 and 100 years. I think there is that famous, quote that people say that if Shah Jahan had got 3 tenders for Taj Mahal and he gave it to the lowest, Taj Mahal wouldn't be what it is. So I look at the change of mindset, and I'm sure that now the government of India also has changed the category of MSMEs. I think now it is up to 500 crores. And so they also feel that, they are thinking in terms of long term. Maybe it's 5% more expensive, maybe it's 10% more expensive. But I would say in long term, it is far cheaper to shift to primary steel. And I think I can see that trend changing a little bit. There are a lot of people, and I think that second generation also, the new generation that is coming, they understand that you have to have a long-term view about everything. Why should somebody have a long-term view about investments and not about the steel that you're using in your own building? Why should you have a short-term view about that? Yes, there is a very big secondary, market, which I think gradually will have to shift to the primary market. It delivers tremendous benefits in terms of, quality assurance, in terms of, availability, in terms of, the reliability that you will get it on time. So I think there are significant benefits, and it might take a little time, but I think there will be a definite shift from the secondary steel to the primary steel because it delivers a lot of benefits to the user.
We're talking about innovation. Can you highlight any lesser known industries or use cases where steel is now being adopted innovatively?
2 examples. I don't know if you are aware, but I can tell you that there was a mandate from Government of India about 4-5 years ago that the data of the Indian customers by Facebook and Amazon and all those will have to be stored in India. There was a mandate from the ministry. So data centers, is where all our this, whatever data we share electronically anywhere is stored. So there was a big flood, of the data centers, which are like, big centers where all the servers and everything is kept, where the data is stored, was to be done. World over, they were not really done in steel, and they were all done in concrete. A data center in concrete or whatever capacity would take 2 to 3 years to build. Whereas if you build in steel, it could come up in half the time. So one of the major examples was that the data centers, which were conventionally made in concrete, are now mostly made in steel. And it has made such a big difference that they are doing them in half the time. So the data centers done for very large groups, I will refrain from taking names, very large groups, in Noida, in Bombay, a lot of places there, the data centers are being done in steel, saving half the time. Second is our solar sector and the manufacturing sector in terms of the process buildings, right? Process buildings will normally be done in concrete or conventional steel. but now they are all done using the high tensile pre-engineered kind of a steel, because it takes much lesser time and they are all factory made. So these are two cases where concrete would be used otherwise, taking much more time, and steel has been used, and it's been a game changer. The last but not the least has been the institutional and multi-story buildings. Hospitals were never built in steel. The commercial buildings were not built in steel. So I think now there are companies and which are taking up the skyscrapers also, buildings up to 30, 40, 50 stories, hospitals, institutions, hostel buildings. They are also being done in steel now. I remember, a hostel building in Jaipur for one of the engineering colleges has been done using steel. An engineering college in Patiala has used steel for making their, hostels and secondary blocks, including food centers. The buildings in Greater Noida, a lot of buildings, commercials have been done using steel. A lot of, hospitals, in Delhi and in Bangalore and in Bombay are being done using steel. So these are few examples, where there is a complete shift from concrete to steel.
So now moving on to modular or quick deployment methods. Are there any which steel construction methods that MSME should explore when it comes to modular or quick deployment?
Yeah. So I think there are two ways. One is anything that is a standard usage, for example, a warehouse of a certain size or a certain, modularity for a certain kind of manufacturing. There are now modular constructions available which they can pick. However, when you have to make it what we call build to suit, then the thing will not be modular, but I will say the thing will be pre-engineered, prefabricated. So one thing is that you have a standard and then you just pick up a ready-made building. And second could be, it is a building which is customized to your usage, which you have specified, and therefore the MSME can get it done in about half the time. So I would say, yes, we can shift to, modular to as much as possible, but only for standard usage. But otherwise it is pretty much product centric, and these buildings will be what we call build to suit, but they can also be delivered very fast because they will still use some modular components. Maybe not the same, but different components will come together to form a different building.
Right. So now, can you tell us what factors should MSMEs consider when choosing between steel or any other material, could be wood or concrete?
I think now that we are all responsible, and particularly if we talk about metros and if we talk about sustainability and pollutions and water, I would say MSMEs also will have to be far more responsible towards the environment. So I think the first and foremost, I think they will have to look at is how responsibly am I using the construction material. So if I use wood, quite obviously we all know how many trees I will have to cut or whatever. One has to be very responsible. Number two is the concrete matter, that if I am using cement, then what am I doing? I'm going to be using a lot of water, which is a natural resource, and I'm also going to be creating a lot of pollution for that matter. So I would say top of the heap, first thing that MSME must consider before adopting any building material technology or material is it sustainable? Is it recyclable? Is it green? That's number one. Number two is how long will it survive in terms of the life cycle cost analysis. That is it going to be, today it may be 1 rupee more expensive, but is it, so doing the life cycle cost analysis of any building material that they are using. That's second part. Third, I would say is, of course, the reliability part, that who's going to be my partner, who's going to be building this for me using whatever technology is available. So third is that whether I will be able to do it in the time and the budget that I fix it. Do I have reliable partners to deliver this particular? Fourth is, again, I will say, the salvage value in terms of at the end of the day, will I get any value back once I have exhausted the time limit for the usage of the building? So I think these 3-4 things they should test and tick. If it ticks all boxes, I think that's the material one should use.
Absolutely right, sir. So how can MSMEs manage the risks of fluctuating steel prices in their supply chains or project planning?
That's a really difficult one. MSMEs, I would say it can't be fully managed. There will be some exposure, definitely, and steel is cyclic, because it can have variations because of, I should say, the global environment, number one. It can also have fluctuations because of the geopolitical situations. Ukraine happened or this happened. Today also anti-dumping and this happening and that happening, and in US what's going on, whatever. So I think they really can't be protected by the major steel manufacturers. Steel will go up and down. I would say how an MSME can protect is 2 ways. Number one, they can try and tie up some vendor financing and try and hedge through the physical stocks for 2 or 3 months of usage. Number 2, and which we have also tried at our company very much, and we have been very successful, is finalize the value with your customer, with your end customer, on what we call the variable price mechanism. Even Government of India allows that, right? There is a delta mechanism, that is there, that you link the contract price with a base steel price of a particular day, and as the steel go up and down, you can link it with some kind of index or whatever, so that you are protected from extreme fluctuations. Means one could fix up that, okay, up to this percent is no problem, but let's say it goes up by 20% or goes down. The customer must get the benefit if it goes down, and then you don't lose anything because you work on the delta. So I would say inventory management by arranging working capital through some vendor financing and all of that. And second, I would say through the variable price mechanism contracts with the end customer, I think MSMEs can quite a bit hedge themselves against the spikes causing stress in their profitability due to the steel price variations. We have been very successful. In fact, we have been very, very successful in variable price contracts. We have done it with many customers and it works very fine.
Could you also tell our attendees what can be or what are the main barriers preventing MSMEs from using steel widely in their construction projects?
One, I would say, is the availability of steel, good quality steel from the primary manufacturers conveniently. I would still say, I think companies like yours and many others are taking a lot of steps in taking, their products very close to the end user. India is a very, very big country, and not everybody can go to a mill and, place an order and buy. People like us can buy. So I think with platforms like JSW1 and many, many other, aspects are there, I think it's a good thing that the steel is, the good steel from primary manufacturers is now being made available. But I would say it is still, there is a lot which can be done. Availability creates its own demand. So if I am an MSME and a good steel, from a primary available next door, I'm more likely to use it. But if I have to make a lot of effort, I will call him and I'll call there and I'll have to go to, a major place. I might say, my contractor will say, sir, it is very difficult to get, let me use whatever is available here and there, cement or this or that or whatever, local steel, this. So they say, okay, whatever. So I think we'll have to make it convenient for MSMEs to source right kind of steel from primary manufacturers very near to me. I think I shouldn't have to travel more than 10-15 kilometers to get the right kind of steel next to me. I think it is the responsibility of primary suppliers to make that kind of an ecosystem. I think that is one big. Second, I think the major steel manufacturers should also invest in getting the fabrication and prefabrication industry to the next level. People like us are, of course, doing their own bit, but I think there is definitely a dearth of what we call good engineered, fabrication companies across India, which can deliver world-class building solutions to the MSMEs in their budget and time. So I think the ISA kind of an organization can do a lot in how can you create the entire ecosystem. Then the installation part aside, because ultimately it is end-to-end. Supplying steel plates of great quality is not going to do the full job. Steel availability near to them, then somebody who can engineer their building, fabricate it, supply, and then erect. That's how I think the entire ecosystem. And I would say the primary steel manufacturers of the country were very big. Plus, I would say, the pre-engineered building or prefabricated steel companies like ours have a combined responsibility. And then institutions like INSTAG and Government of India, they have a lot of responsibility put together to make it very convenient for the MSME to use this for their buildings. And then I think the usage can explode. So I think that the 2-3 things we could do.
We talk about recycling now. What is the role of steel recycling in reducing carbon footprint, and how accessible is that to MSMEs?
I would say it has a great role to play in reducing the entire carbon footprint. There is no doubt about that, because you can understand how much of concrete each kilogram of steel reduces for how many years, very clearly. So there is a clear cut. You use steel, you reduce carbon footprint automatically. And then when you reuse steel, when you recycle, and I think it can be recycled any number of times. I think there is no finiteness, means it can be recycled 100 times or 1,000 times. It doesn't really become zero. So I would say, yes, it does reduce. And in terms of MSMEs getting access to that, I think there is a lot of work that has to be done on that side still. I think the way our steel collection mechanism and what we talk of making steel using green hydrogen and other things, I think that is still in its infancy. So I think its access to MSMEs will have to be increased by a lot of initiatives, like having maybe blast furnaces close to them or whatever.
So now, for our attendees' sake, can you share an example of a project where steel helped to overcome geographical or climatic challenges and conditions?
Yeah. So I would say quite a few examples actually. It is extremely hard to build in cold climate and in hilly areas. So a lot of buildings, residential, buildings or industrial buildings, particularly residential, I will say, are made, in high altitudes. We talk of Leh Ladakh, we talk of, Shimla. It would have been very, very difficult to make that in conventional materials. So there have been, clubhouses, and there have been residential buildings, and there have been industrial buildings in high altitude areas like in Bhutan or Leh Ladakh and all. In fact, as we speak, we are building stadiums in Ladakh. It is impossible to build otherwise, using steel. We have built resorts, multi-story resorts, clubhouses in Shimla using steel. So I think that has helped put those buildings together in less than 6 to 7 months, and a similar cost or a lesser cost. Otherwise, a building in concrete conventionally would have taken 2 years, and we're not very sure what kind of quality. See, what you are assured of in such things is also quality, because it is all factory made. I think these are 2 examples. Leh Ladakh is a very difficult terrain. and Shimla equally difficult, I should say. And there have been institutional residential kind of buildings that have come up. Shillong is one area where a lot of buildings have come up using such technologies.
Great. So, how can MSMEs future-proof their business by adopting steel-related construction practices or technologies today?
See, future-proofness, 2-3 ways. Number one is, I don't think I can give that example, but I will try and hide names. So there is, what Gurgaon was 30 years ago and what Gurgaon is now. So there was an industrial unit right on the Delhi-Gurgaon, expressway, which is now the expressway. So that person, had sold his building. Now we know what Gurgaon is all about, those cyber city and all that. And you have Udyog Vihar on your right. So I should say that somebody who had a building there for making industrial products, let's say 20 years ago, 25 years ago, had to shift because that real estate now is humongous. Why would somebody do industrial? So I would say steel comes handy there. So because cities are expanding, they were like in the center, now they expanded outside, then further outside. So the cities are expanding and the industrial units are going more and more. So you need to relocate. There is a need to relocate. All steel buildings doing prefabricated way are relocatable. So let's say you have made a building today in Bhiwadi for that matter. Bhiwadi will become Gurgaon, let's say 10 years down the line, and you will have to go further away. Now, how will you take your concrete building away? You will have to break it down or you keep operating. So you open the nuts and bolts of the steel building, you take it to your new place, and this place, maybe you have a commercial or a IT building coming up. So I would say steel helps future-proof MSMEs business because they can always relocate it. Number two, in future, if the building usage change and you say, I was making, let's say, electronics. Now I want to make automobiles. Building doesn't suit me. You can take out the building, sell it. 30 years ago, steel was 18 rupees a kilogram. Today it is, let's say more than 55 rupees a kilogram. Today, the cost of scrap of steel is more than the original cost of steel 30 years ago. So you get straight away money. And then you also contribute. So that also, in a way, future-proof. So you get a lot of capital cost, recovered. And third is, I should say, they are very futuristic. You can always expand them in any direction, right, left, up. Steel is far more, expendable compared to any other form of construction. So I think these 2-3 things do help MSMEs future-proof their business by using steel for sure.
So my last question to you today is, what kind of skills or training will the workforce in MSMEs need to stay relevant in a construction or steel-driven construction future?
I would say I'm a civil engineer, and I think the other day also we were talking that our reinforced cement concrete, what we normally call RCC book used to be this thick. Whereas our steel design book used to be very thin. So steel, steel has not really been taught in the manner that concrete has been taught in engineering colleges. So I think we'll have to start it young. We will have to, and there is a lot of work going on that, we will have to perhaps start from changing the curriculum in the engineering colleges, that how to use steel more and more for construction or any other usage. That's number one. Number two is, engineering you have done. Now, what about producing right kind of steel and using, right kind of steel to manufacture certain products? So I will say upscaling the fitter and welding community in our ITIs. I think there have to be specialized courses. Again, I would say there is a lot that is being done in training the engineers to work with steel. So I would say overall, the entire ecosystem, right from school colleges to the sites. See, you will find a mason, tiler, what we loosely call mistri and all those people. There are a lot available. But if you look for a fabricator, they are still not as much available. So I should say that entire ecosystem, right from people who knows how to erect steel to how to do the roofing cladding, going back to how to, fabricate steel in the right way, fitters and welders and engineers, then the design engineers who can do the right kind of steel structure design. Entire ecosystem will have to be created for MSMEs to stay relevant in this entire space. A lot is being done, and I think a lot is still to be done. And I should say in last that primary steel manufacturers, and looking at the kind of steel policy Government of India has taken out, Indian steel policy very clearly says that the production has to grow 3 times, the consumption has to grow 3 times. But the entire ecosystem has to be supported, and I think those people must take a leadership role along with companies like us to take the entire ecosystem to the next level for building in steel.
With that, we've come to the end of today's episode. So thank you so much for taking time out from your busy schedule and helping our attendees understand such an important aspect of future of construction with steel. Thank you once again, sir. It means a lot.
Thank you very much. I hope it was useful for all the listeners and all the viewers. Thank you very much for engaging with us, Amrita. It was a real pleasure talking to you, and I wish all the best to JSW1 MSME.
Likewise, sir. For our attendees who are online, if you would like to see the current episode, if you've missed any part of the current episode, please go on YouTube, type JSW1 MSME, and you will find all the episodes uploaded there. Thank you once again, sir. Bye-bye.
Bye-bye. Thank you.